Hey everyone, welcome back to the shop, and we are going to continue on with the machining for our new Vise spindle here. In today's video, what we're going to be focused on is getting this hole drilled and bored in the new spindle there in the ball end. Get this completed, and whenever we get that finished up, we'll probably go ahead and move over to the Precision Matthews lathe and do some turning and threading on the new handle right here. All right, so this is the original handle that comes with the vise, with the hardtail, and it works great. I believe this was, Jason told me that he uses 4140, so I believe that's what this is made out of. They go through a process where they form this in. They probably got some kind of die and they heat it up and they press it. All right, and then the other end of the handle, what they do is have it turned and threaded. You got these little rubber boots on here, rubber square O-rings that kind of protect your hand from it sliding down, okay? But the other end is turned and threaded, all right? So I'm planning on doing the same thing with our handle there as well. I'm not going to worry about these grooves in here. These are put in there. Jason designed this so that these grooves, the purpose of them is that when you have this vise handle in here and you're pulling on this handle, if you over torque it, it's supposed to bend at one of these grooves, indicating that you have applied too much torque to the vise. You don't need to put that much on there, and you can simply take this vise handle out and replace it with another one if you want to. So we're not going to go with these grooves into my handle, but we are going to replicate something that looks very similar to this here. And for that, I got this piece of material. I bought this from McMaster Carr. This is the 440C stainless steel. But what it is, it's 17-4 stainless that's been case hardened and in precision ground on the outside. 1 foot length, so it's 12 inches long. And these things are super smooth. I mean, they're like polished finish. It's just, it feels like glass. Should be a nice strong handle. I've seen other people use the same exact material for vise handles. Seems to work well, so that's what we're going to do. So once we get our whole precision board in there to fit our new handle, we'll go over to the lathe and we'll do some turning and threading for the ends. I'm going to turn and thread the ends 1/2 20. Believe this handle is 15 millimeters. It's been a little while since I measured it, but it's a little bit bigger than 1/2 inch. I'm going to be using imperial sizes. So we'll do some turning and threading on the ends for 1/13. Get that done. And then this is going to be a separate video. Hopefully the next video down the line. I bought 2 of these balls here from McMaster Carr as well. These are stainless steel. They're soft. They're not hardened. They're not ball bearings. They're just stainless steel. And I'd like to set these up in our CNC mill and basically just replicate it. We're going to do the same thing. Clamp it up and mill it and counter bore it with an end mill, and then maybe use a thread mill to go ahead and thread it to the 1/20 and just make it look like that. Now I went with a larger size here, so the Fireball ball end looks to be around, okay, so 1 inch ball, and I went with 1 1/4 inch ball. I just wanted a little bit more material there in the hand whenever you're using this new vise handle, okay? So we'll do this. We'll focus on this in the next video, and hopefully that's going to work out pretty good. So we got a couple drills here, so we'll go ahead and get a hole down through there. We've got our criterion boring head, so we'll set this up and use this to get it bored on size the way we want. We've got a bore and bar right there that we'll use, and my goal is to try to get this fit really nice and tight. You know, 1/1000 or under is what I would like the tolerance to be on our precision fit whenever we go to bore that out. So we'll go over to the manual mill. That's what we're going to use, the KBC mill, and go ahead and get this end of it finished up. So we'll use our KBC mill today to get this job done, at least for the drilling and boring anyway. I've already got my Vertex 6-inch spacer set up here nice and square and indicated, ready to go. So we'll hold our spindle right here. Probably set up a machinist jack underneath here to kind of support the, we got a lot of pressure going down for the drilling. So support at least for the drilling, and if we need to, we can move it out of the way for the boring head. So anyway, just wanted to show you the machine we're going to be using today, and we'll go ahead and start getting the workpiece set up now. Let's see if we can get it through here nice and gentle without scratching or denting our thread there. There we go. And we'll just bring it right on up to the face there. And chuck it good. And that should work pretty good right there. I've been using these Vertex spacers for many years now. Dad and I started out with one long time ago, the 8-inch super spacer. That's what we have. That's what I have at the home shop. And this one is the 6-inch simple spacer. So the difference between a simple spacer and a super spacer is the super spacer is set up a little bit more like a dividing head. It has the worm gear in there. It has a handle that you can put on there and actually rotate this chuck around more accurately like you would when you're using a rotary table. The simple spacer, which is what we have, is just designed, you can set it up to where it just free spins if you want to, but it's set up so that it locks in at every 15 divisions. So there's a pin back here. You can't see it, but on this back side, there's a little flap, a little lever. You pull up, that disengages the pin from the back of the chuck. So you just pull that pin, and I use this little ball oiler at the top. It's just easiest to read. I put a little white mark on there, but you can put a hash mark anywhere you want to. I use the ball mark as my reference for top dead center. So I have the 0 lined up on that, and so if you just go, you can let go of that, and once you pull it around 15 degrees, it locks in. Okay, so that's a real easy way to drill a series of holes, 24 divisions total if you want to. These usually come with backing plates so that you can block off those holes in there, and you can do like a 3-hole pattern, a 4-hole pattern, a 6-hole, 8-hole. They have a bunch of different ones you could put on there so that if you're trying to go through a job very quickly that has a series of holes, you don't have to count and keep up with where you're at. So that can be handy for certain jobs, but I don't ever take the time to take this plate off there and change the backing plate out. I just always leave it just the way it is. But if you want to set up to do like squares, if you want to mill a square or 2 flats, I always use these whenever I was machining those hydraulic rods. There's always flats on there that you can put a wrench on there when you got to screw the rod end on. So I always put the hydraulic rod in here, mill one side, rotate it 180 degrees, you know, and then mill the other side. It works perfect for stuff like that. You have a lock up here, so it locks in the chuck, you know, supports it really well. So anyway, I just wanted to point this out because it is a tool that I've used many times. I mean, probably thousands of different jobs. And I do have people ask about it, so I just wanted to point this out. The Vertex brand, I bought this from KBC Tools. That's where you can get yours. You can get it in a 6-inch, 8-inch, simple spacer, or super spacer. So if you don't have one, I'd highly recommend adding one to the arsenal. All right, we've got an edge finder in the spindle. Let's go ahead and find the center of the ball there. Just want to find the center of it up and down like that. It doesn't really matter if we're not dead on the highest part of the ball there. You're going to be touching in the y-axis here evenly. All right, I think that looks pretty good. Let's go ahead and kick this on. Speed it up some. Bring it over till it kicks off like that. We're gonna zero out our y-axis. All right, I gotta do something up here on the control. I was in the wrong setting. Okay, 0 set, all right. Over here and do the same thing. Kicked off, 2.9996 on the DRO. Hit half, y-axis, 1.5 inches there, and we'll just bring this back over till we get to our 0, and that should put us right there in the middle. There we go, just like that. All right, we'll put a drill in here, or a drill chuck, and we'll go ahead and get the hole drilled out before we get it bored. Let's go ahead and get a machinist jack underneath this. I want to support this ball for the drilling. It's probably just fine, but I think I'd rather go ahead and support it just in case anyway. So I've got these Edge Technology Machinist jacks that I've been using, and they work really good. So I thought I would point that out and show you what they are, because I've had some folks asking in some of the past videos. So this is one of the newer tools that Edge Technology makes, and they also offer a riser, so you can get the spacer here that will bolt on. Actually, I got one in the box already put together, so let me show you. I'm sure this is one you've seen in a previous video. So you can get it, you can get the extra riser if you need more length out of it, and of course you can stack these if you need even more than that. So, but the one without the riser I think is going to work perfect for our application right there. All right, so we'll go ahead and get that set up. It does come with a bolt and a T-nut there as well with that, so that's an extra little bonus. All right, but I think what I want to do is, let me find some kind of spacer. I think what I'd like is some kind of soft material that we can put between the pad and the ball, the spindle, so that we can support it. But since we're drilling right in the middle, that's where the jack's gonna be touching. If we put like some aluminum or bronze or something in there, it'll support it, and then I'll know when the drill is actually coming all the way through there. And then once we get that drilled, then we can just move the jack out of the way. So let me see if I can come up with a little piece of material that we can put on there. All right, I found a piece of aluminum, and I went ahead and cut it and dressed it. So you can see all the bandsaw marks on there. And I just hand cut it. So I think what we'll use is this. I think this will work pretty good. This will allow me to support it and then let the drill, you know, so this is a sacrificial metal at that point. Just like a little soft pad that we can put under here and support it and drill down into. And I think that'll work pretty good. I've already got a stud, a T-nut and a stud, and a flange nut here that we can use to just go ahead and kind of lock it in place. Go ahead and do that. All right, and now we can we're just gonna hand tighten it. There are a couple holes drilling it, so you can take a little rod or something to use as a handle to snug this up, but it's knurled as well, so I think just hand tighten it just like that, that's gonna be pretty good. All right, I think that's gonna work well for our drilling. How many of you said, well, you didn't find the center in the X-axis? I was just waiting to see how many of you were paying attention. Yeah. Let's go ahead and do that now. So our ball measures right on 2.5, so we're just gonna find the end of it and offset it accordingly, which is gonna be 1.25 inches. There we go. We'll just hit 0 on X, and we're gonna move it 1.5 inches. So half of the diameter of the ball, 1.25 inches, plus half the diameter of the edge finder, which would be 1/4 inch. And there we go. We should be right in the middle of that ball right there. All right. I think instead of fussing with a drill chuck in here, we're just going to go straight into the 1/2 inch collet. So I've got a 1/2 inch Cleveland spot drill. We got a 1/2 inch diameter Chicago Latrobe drill bit right there. And then we'll go in with a 23/32. This is also Chicago Latrobe. This will just open up the hole close to size, give us about 30 thousandths to bore out. After we get it drilled, we'll put our boring head in there and get it bored to a precision size. So we'll just start with our spot drill, get it spotted, and then go ahead and get it drilled. For a lubrication today, I'm going to use my mister there. I've got a fresh tank mixed up of the trim mist from Master Fluid Solutions, and we're going to use our Noga Mini Cool right here for that. Let's go ahead and get it set. Looks like it's about ready to go now. Turn that off until I'm ready. This will provide coolant and lubrication for the drilling. There we go. All right, table's locked, spacer's locked. I think we're ready. Let's go ahead and get it spotted. And I'm gonna slow that down just a bit. Come on. One thing about spotting drills is that they definitely cause a little bit more movement than just a center drill, but a spotting drill is the proper drill to use there. All right, so we've got it spotted, and we'll go ahead and swap this out with our 1/2 inch drill now. And I got to bring it down some. All right, there we go. See if we got enough travel. I might have to come back up with it. I was just trying to get my mister there set up, ready to go, and I have the worst luck with these guys. You can see what it does. It sprays nicely just where you want it, and then it just quickly decreases to where it's not spraying anything, and you just come up here and touch the end. So you end up having to spray a little bit more than what you're really trying to in order to keep it spraying. And I'm sure it's just because this tip needs to be taken apart and cleaned, which I never do. So I'm griping about things I can fix, but sometimes you just want to go. So I'll just adjust it as I need to, about like that right there. All right, let's go ahead and get a 1/2 inch hole drilled down through this 4140. All right, we're coming through. We're starting to, oh, that was a hot chip I just landed on. Tighten that up a little bit, try to keep it from spinning. You can see that it definitely wants to. All right, I think the safest thing to do is just go ahead and move this out of the way. Let's go ahead and we'll finish this last little bit. Oh, there we go. It was all the way through there. Okay, 1/2 inch hole. Now we'll go ahead and we'll put our 23 30-seconds in there and open that up. Okay, 23 30-seconds installed. We're ready to drill. Got it slowed down. We're running, this is around 225 RPM right here. breaking through. There we go. Okay, we've got our Criterion boring head set up there. This is a boring bar. It's made out of high-speed steel. It's going to work really good for boring this out. So we've got approximately 30 thousandths to come out of there. I'm planning on using my telescope gauge and micrometer to measure it. And we've actually got enough room here where we can come down in the bottom with our telescope gauge. Let's see if I can go ahead and get a measurement on this. Should be about 30 thousandths to come off. So that's measuring about 721. So just under 30 thou is what we're going to be, is what needs to come out of there. All right, so I'm going to go ahead and get this tool touched off, and to do that, I'm just going to go ahead and I'm just going to eyeball it. We're going to run it over. And what I'm doing is I'm just running the bar up and down, as you can see, and I'm moving it out, and I'm just going to wait for it to touch the side of that hole. It'll start scratching it when we're there. I just can't tell how far away we are. Let me go over until it, there we go. Back it up. Now let's try it again. There we go. Now it's trying to cut. So that's probably 2 or 3 thou that it's trying to cut right there. And we'll go ahead and on the dial up here, let's take 10 thousandths. And 1 division is 1 thousandths on the diameter. And I hope that it's not going to lie to me. So that's 10 thousandths right there. And we'll go ahead and snug up the lock. And then it's ready to bore. So the lock, this brings up another topic. Last time I used this, there was quite a few people that left a comment telling me that I'm not using the boring head correctly. And I've used these boring heads the exact same way ever since my dad showed me how to use them when I was 17 years old. All right, not saying that I'm right or wrong. What I'm saying is that this is the way that I've always used it. You have the center, it's even etched on here, it says lock. So this is your lock that pushes against the gib when you're ready to do the cutting. Otherwise, if you don't lock it, it's liable to move a little bit on you, especially if you have an interrupted cut. The vibrations will make that screw move a little bit. But what people were saying that I was doing wrong is that you shouldn't lock this and unlock it, because you're actually causing it to move every time you do that. If you lock this, you're actually losing the accuracy of what you just offset that. I don't agree with that. In fact, I don't agree with it so much that whenever I was at FabTech last September, American Machine and Engineering, they were there representing, and they had some of their other cutters there, but they had one of their engineers there that work on the Criterion boring heads. So I brought that question up to them straight from the viewers, and I said, look, the viewers are saying that you should never lock and unlock that because you're going to change your diameter, and that you should leave it unlocked and use your gib screws there just to keep it kind of snug. And they agreed with me and said, nope, that is not correct. These gib screws are adjusted, and in fact, those are adjusted from the factory, and they put this wax or whatever that is in there so that people can't mess with that and lose the adjustment on there. And that you should lock it in the center here when you're ready to make your cut. So the way that I've been using it is the way that I knew that was the right way to go about using the boring head, and the engineer at Criterion or AME confirmed that I was right. He agreed and said that's exactly how this boring head is designed to be used. Now you guys can disagree with me, and that's just fine if you feel like you get better results by not moving this screw. And you can get great results with that if you're just doing a light bore. Like what we're doing here, you really don't need to lock that. But I've always been in a habit of locking it just to make sure that the screw is not going to vibrate one way or the other. So that's the way I'm going to continue to use it, take it for what it's worth. And I appreciate the guys at AME talking to me about that and trying to clear up that subject. All right, so we are ready to make our first cut. So let's get the mill set up to use the boring head here. I am gonna be running in low gear, so we're all the way back in low gear. All right. You wanna engage your quill feed right here. So that one in, all right. And then when we're ready to bore, just simply engage that lever, and now it's feeding down. Your feed rate's over on this side. I've got it in 3 thousandths per revolution, but let's go ahead and take it down to 6 thousandths per revolution. That'll feed through there twice as fast as what we had it. When you're ready to disengage, you just do that right there. Just simply, it's got to be down just a bit. Engaged, disengaged. All right, I think we're ready to make our cut. Left a nice finish in there. Yeah, it looks good even at that 6 thousandths feed rate. We'll go ahead and measure it, see where we're at. We'll probably do this in 2 or 3 cuts, probably a minimum of 3 cuts. I want to be able to sneak up on that size, and hopefully we don't overshoot it. We want to try to hit it within 1/1000th of an inch. Right at 735. So we got approximately 15 thousandths to come out of it. Loosen the lock. Let's just move it 5 thou. Snug up the lock. Make another cut. Go ahead and give it a measure. $741. So we have about 9 thousandths to come out of it. So we'll go ahead and make another adjustment on it. Let's go ahead and measure our bar stock here. It's a 3/4 nominal size, but we need to get an actual size on this. All right, so that is 749 3/10. $749 3/10. That was 749 2/10 right there. 749 3/10. Honestly, what I'd like to shoot for is 0.7495. Technically that would give it about 2/10 of clearance in there. That's probably going to be too much, but I think my buddy Alex Brown would appreciate that, caveman welder, if I got it within that range. But we're going to try to shoot for no more than 1/1000 clearance. I'm going to try to, but let's see if we can do it. .746, 746, and 3/10. So we don't have far to go. Let me, what did I say the bar was? I think it was 749.3. Yeah, 749.3. So we got technically about 3.5 thousandths to come out of it. So it's going to be tricky. Let's see if we can do it. So we're just going to adjust it 3 thousandths and see what happens. 1, 2, and 3. All right, and then let's go for it. All right, we're through. I think we did good. We are slightly undersized, so I'll show you the measurement here, tell you what it is. So we're at 749 and 1/10. So we're right on it. Right now it's a couple tenths small, and that's what I was shooting for. I wanted to try to get it right on size so I didn't overshoot it. So hopefully I can just go ahead, and what we'll do is crack it and just barely move it and let it run through there again, almost like a spring pass, and see if it'll take about 1/2 thousandth out of it. I am going to measure it again just to be sure. .749 and 1/10. I got the same exact reading that time that I did previous, so let's go for it. I just barely moved it. Trying to get a little bit of a spring pass with maybe a few tenths out of it there. Got a few. It's got a little bit coming out of it, so it's doing good. Something else I might want to add to this, using the boring head, is I've seen quite a few guys show this, like on Instagram or whatever. You just using a boring head, I mean. And oftentimes, I think they're running them too fast. You don't have to spin the guts out of this thing. It's more of a slow speed operation to me. It's a little bit more slow and controlled versus a CNC. But I think guys are using it kind of thinking the feeds and speeds on a CNC mill. And to me, we've always just used it slow and controlled. And it helped reduce chatter and vibration that you might get in that. The faster you run that, the more it's going to want to chatter and vibrate on you. So slower speeds for me, that's what I've always used on a boring head. All right, we'll clean it out and measure it again. The hole looks nice. I think my camera lady forgot to get me using the telescope gauge, didn't you?
You threw me right under the bus.
I did. So I'm seeing what we have here. I think we might have nailed it. So 749, 5/10. 749.5. I'm going to measure that again. Let me see. That is going to be so close for that bar to fit in there. Come on. Try to get it to where it just touches. You don't want to force it, you just want it to touch. So that time, I got 7/10 that time. What I say, 5 the first time, so 2/10 difference. So what we'll do is go ahead and I'm going to take this, the spacer. I've got it set on 0. I'm going to go ahead and rotate it 9 degrees so that we can see if the bar is going to fit in there just like it is. So I'm going to scoot over here to this side and we'll go ahead and unlock it and rotate it around to the 270 degree mark. I'll put it 90 degrees out, and that way we can easily see if it's going to fit in there. Now we're not through. I may even have to run the bar in there again. We're going to mill a slight little flat on both sides, and then we want to chamfer the edge too. Here we go. So close. See, I think that's too close. I think it's just too close. You can't hardly get it in there because it's so close. It's too close. It's going in there, but you're talking just a few tenths clearance, so it doesn't really want to slide in very well. I actually didn't measure this for roundness either, so let's see. Yeah, it doesn't look like it's perfectly round. 1 or 2 tenths difference on roundness, so not absolutely perfect. Remember, this isn't like a gauge, you know. It's not a precision tool. It's just a piece of bar stock that you use. So there's going to be some slight variations to it. I think we just got it too tight. I need to go through there again and see if we can get maybe another few tenths out of it, a half a thou, and see if we can get that to slide in there, because it's just too. You can't use it with it that close. We need a little bit of slip fit in there. Let's try it again. I'll go back up to our 0 and lock it in. Just barely moved it. It's taking some metal. See, that is just so close. You're liable to gall it going through there. It's trying to go. You can see that it's trying to go in there. So now we're hitting the high spots of the tool marks. I don't want to force it and get it stuck, but we got it. We got it going. I'm just afraid it's going to get stuck. Not really ideal. All right. Oh man, that's so close. So close. About as far as I can go comfortably. Starting to get a little tighter. All right, I'm gonna keep playing with this thing. I don't wanna keep showing you the same video over and over again. I'm gonna make another pass through there, and when I have it ready, I'm gonna bring you back and show you. You can see that we're right on it, but you have a slight variation in the bores, the little tool marks from the boring bar, and some of them are sticking out a little bit more than the others. You know, you're talking a tenth or two, and that's what's jamming up the bar there. I remembered that I had a few reamers on some specific sizing. This is 74. I'm sorry, 0.7495. So it's a half a thou under 3/4 of an inch, and it's right on what we've got it bored to. And this is a new reamer. Let's stick this guy in there, 749.5. Let's stick it in there and see how it feels. I'm just getting some cutting oil over here. Put a little bit of cutting oil in there. Let's see what happens with this. It feels like it's right on the same size as that reamer, but it may have taken off some of those tool marks. I see a few shavings on there, not much. Let's see if that actually did anything for us there. Hopefully it cleaned that hole up. There you go. There it is right there. That's what I'm talking about. We got it. That is beautiful. Leave it up to the good old hand reamer to get the job done. That was awesome. Well, I'm happy with that fit. This is exactly what I was trying to get to right here. I wanted to have a nice sliding fit, but it be close enough that you really don't feel any wiggle in that at all. All right, so I'm gonna call it. I think we landed on the bore. Not gonna take any more out of it. Real happy with that. All right, so our boring is finished, and the next thing what we're going to do is, if you look at the original spindle here, you can see they got a little bit of a flat. We're going to do that. We're just going to duplicate this, mill a flat, and I want to put a chamfer tool in there. And this will also give this is the O-rings that I'm going to be using, and it'll, you know, give it a nice flat place to sit down like that whenever they're installed. So I'm going to find a cutter, see which one I decide that we're going to use, and then I'll bring you guys back when we're ready to mill those flats. Okay, moving on. I decided we're going to use this Walther face mill. It's a 2-inch face mill. This is the M4132, and it does a good job. We're just making a flat there, so let's just go ahead and get it done. Just going to bring it down close, and then I'll bring the knee up. I'll bring the knee up to touch off on it. In fact, I'll move you around here so you can see that a little bit better. I think that's pretty good. We'll just go ahead and run it up a little bit now. Yeah, it's pretty close right there. I'm just going to touch it and move it back in the x-axis. Let's put it in high gear. That is 800 RPM. I want it to try to hit the very top dead center of that. All right, there's our touch. Yep, got a little flat on there, so it ain't gonna take much. I'm just gonna run it up. This is 10 thousandths right here. Let me come over here to this other side. I'm just gonna run this by hand. I'm on the left side of the mill here. Oh yeah. That looks pretty good. Let's go up another 5 thousandths. It's looking pretty good. I'm going to drop this back down to our 0. Come off of it so I don't scratch it. That's looking pretty nice to me. I think that's more than enough that we need to get on there. But I think I am going to take a little bit more, so that was 15, right? Yeah. So let's take another 5 and see if it widens it out just a little bit more. This is all visual. There's nothing to measure here. Hand feeding. Drop it back down to 0. I think that looks good right there. And I think that'll work pretty good there too. So we went 5 thousandths. I'm sorry, total of 20 thousandths on that. So we'll go ahead and rotate it around and do the other side just exactly the same. All right, so we'll rotate around 180 on our spacer. We're going to drop that down, and I'm going to move my air hose so I'm not stepping on it. All right, there's our flat. It was 2 thousandths difference from the other side. That was 10. And another 10 makes 20. Bring it back down to our 0. All right, and there's our flat. It looks good. All right, so we'll take this face mill out. I've got this chamfer tool. Here's a 90-degree chamfer. We'll put it in a collet, and we're going to come down and we're going to just break that edge. Maybe take, 5 thousandths chamfer or so. All right, we got our chamfer tool set up in there. All right, so we want to lock that, not touching yet. That's a good speed right there. One, 2. I'm just getting where I can see it. I'm going to go a little bit more. So 1, 2, Brought it up 5 thou. 2. That looks pretty good. 3, 4, 5. Got a good chamfer on there. All right. So we'll go ahead and rotate it around 180 degrees. Come back up 5. 1, 2, 3, 4. There's our 0. There's our 5 thou. So 1, 2, 3, 4, 5. There's our chamfer brake. Looks pretty good. I think we're going to roll with that. I think this is finished up. I'm liking it. Here's another fun way you can measure that hole using your pin gauges or plug gauges. This one is a 750. This one is a 749. 749 goes in there, and it has some resistance going through, you can see. The 750, it doesn't quite want to slip in there. I can't get the 750 in there without forcing it into the hole. You can see how it gets stuck. So that just tells me that the diameter of your hole is going to be between 749 and 750. All right, our machining for the new Vise spindle is finished. So let's get it out of here, get it cleaned up. And I want to get it coated down with some CRC to protect it, because this is bare metal. Try not to scratch my threads there. This has been a fun project. I've enjoyed making this. Just making sure all the chips are off of it. There is our new Vise spindle for our USA made hardtail vise. 4140. Our threads turned out beautiful. The ball end turned out beautiful, and I really like the precision fit that we got on the cross hole there. This guy's finished up. Like I said, let's go get it coated down. I want to keep the flash rusting off of it. All right, so I'm going to use my CRC SP350 rust inhibitor. This is one of my favorite products of theirs. And we're going to give it a coating. And what SP350 does, it's a rust inhibitor for indoors. So you just coat down your bare metal surfaces, and the moisture in it kind of evaporates after a little while, and it leaves a nice oily film on the bare metal surface, protecting it from flash rusting. That's it. We'll just leave it right there and it'll start drying. And I'm going to hit that a little bit just like that. All right. That is finished. The next phase is going to be our handle right here. We've got our piece of Thompson's hardened shafting there. So that's what we're going to jump on next. Get this guy machined and get our spindle completely finished up.